Dear college math students, we're going to do some predictions. We're going to use the graph to do some graphical predictions, and we're going to check those using the equation of the line of best fit. So the graphical predictions are reasonably accurate, but they're always a bit less accurate than the equation by the nature of the fact that we need to use the scale of the graph to decide on the number, and that's always a little less accurate. So, first thing, we're going to predict the weight of a bird that's been given 14 grams of hormones. And so what's happening here is that they're administering hormones to chickens, and usually if you have a growth hormone that's given to an animal, it'll cause an increase in its weight, it'll cause it to grow more. So we're going to test that theory in this situation. So 14 grams. Now on the graph, 14 grams of hormones is roughly 12, 13, 14, so about here. So I'm going to go up to the line from there and then across. Oh, sorry, get that back on the go. Okay, and then across from there. That comes in about here, which is close to about 2.3, maybe just under, but close enough, we'll say, to 2.3 kilograms. So the graph predicts that a bird which is administered with 14 grams of hormone will weigh 2.3 kilograms. What does the equation say? Okay, so we're going to substitute into this equation here for H being 14, so weight, I'm just going to use W for weight, and this is what we do. We put 0.068 and then we put a 14 where H goes. So this 14 grams of hormone means H is 14. Okay, so if we put that into the calculator, we get this number, 2.327 is our answer. So that's awfully close to what the graph said. Reasonably accurate prediction from the graph. Alright, so let's go to the next one, and we're going to predict the amount of hormone that would be required to produce a bird which is 1.8 kilograms. So we're substituting into the Y variable here. So that means there'll be some rearranging required. So first though, let's do the graphical one. So we're going to go across and down. Okay, so here's 1.8. We're going in the opposite direction, across and down. And we see, I think it's about 7 grams, judging from this graph, close to 7. So let's see what the equation says. So we're going to need to substitute like this. It's a bit different to the first one. So instead of putting a number in where the H goes, we're putting in W equals 1.8 into the equation. And we're going to rearrange and get the H value. So this 1.8 here means that W equals 1.8. That's what goes there. Okay, so we rearrange the equation. You guys have had lots of practice at these. This is what you should get. Subtract 1.375 and then divide by 0.068. Okay, so when we put that into the calculator, we get 6.25 grams. So a little bit off what the graph said there, but maybe the way I went across and down wasn't all that accurate, but yeah, not too bad, not miles off, just a little bit. Okay, last one here is F, and this one we're going to predict when H is 22. So we're back to putting in the H variable, no rearranging required here. So if we look on the graph here now, one thing to note is that when we go at H is 22 here, we go up and the line's not even extended that far up. So I'll just extend the line, but what this is pointing to is a prediction from outside the bounds of the data that's been collected. So that's not very straight. I'll try that again. Okay, so whoops-a-daisy. Oh, we're looking up the weather now. Stick with me. I'll just get back into there. Okay, and that's about there. So about 2.8. Okay, so definitely looking at something outside the bounds of the experimental data, which of course is called an extrapolation. But first, let's work this out and see what the equation tells us. W equals 0.068. Putting 22 in where h goes. And this gives us 2.871 kilograms. So pretty close to what the graph said. 2.871 compared to 2.8. So the graph was pretty accurate for a couple of those. It was really only the middle prediction where it was off a bit. Okay, so in part G, we're asked about reliability. Which of A to F, which of our predictions are reliable? Well, really A, B, C, D, and A and B are the same prediction. So we're just going to say the three predictions, really. Which of your three predictions? Okay. So the first prediction for when 14 grams of hormone are administered, that was within the bounds of the data. So the least amount of hormone is 0 and the most amount is 18. So 14 sits within that. So that's an interpolation. So the first prediction, A/B, first prediction, is reliable because it's an interpolation. It's within the bounds of the data. Now the second one, let's see, we were looking at a weight of 1.8 kilograms for a bird. Now, if we look at the data that was collected, we have, for weight, we go from 1.3 is the lowest up to 2.5. So this weight of 1.8 kilograms is within those within the bounds of that data. So this is also an interpolation. So the prediction C/D, that second prediction, is also reliable because that's an interpolation. What about the last one? Well, we did talk about the fact that it was an extrapolation. That the line doesn't even go up that far, and 22 grams of hormone. Well, if we look at the level of hormone, the range was from 0 to 18. 22 is outside of that range. So this is an extrapolation. So not reliable. So E/F, the last one, is not reliable because it's outside the bounds of the data. It's an extrapolation. Right, so now go ahead and try some of those questions that were set in the description for the video. You use the equation and the graph to make predictions, and then you need to decide how reliable those predictions are based on which ones are within the bounds of the data, interpolations, compared to those that are outside the bounds of the data, extrapolations.